Hey guys, before we get started, check the description of this video. There is a link that will take you to my website, and on that website you can click right here, note sheet for example 2, if you want to print out the sheet that I will be using in this video so that you can follow along and take notes with me. Let's get started. Continuing in this example, we are now going to graph this piecewise function. So I'm going to do that the same way I did for example 1. I'm going to make two tables. Just want to stay consistent with my colors. Okay. I'm going to make a table for the first piece. But in that table for the first piece, we have the restriction that x is less than 2. And we have the function x minus 2 squared. And I'm also going to make a table for the second piece, negative 3. But for that piece, we have the restriction that x is greater than or equal to 2, but less than 7. And we're plugging into the function negative 3. Now, before we get started, I just want to talk about what those two graphs look like individually. If you are familiar with transformations, and if you need help with transformations, I have a video up that goes through some examples of transformations. In that first function, x minus 2 squared, what that minus 2 does is it shifts the graph 2 units to the right. And the original graph is just a parabola, x squared, so that entire graph looks like this. A U-shaped with its vertex over at 2, 0. Now we won't see all of that when we graph it because we have the restriction that x has to be less than 2. So we'll only see the left half of that parabola when x is less than 2. For the second function, that negative 3, y is equal to negative 3. That graph is just a horizontal line that hits the y-axis down at negative 3. So that graph just looks like this. Just a quick thing, sometimes people say a straight line, which as a math teacher I say every line is straight. It doesn't make sense for you to say a straight line. You can say a line with no slope or a line with undefined slope, whether you're talking about a horizontal or a vertical line, but all lines are straight. So this is what y is equal to negative 3 looks like. Again, keep in mind we won't see all of this. We will only see the part of that graph that falls between 2 and 7. So we'll only see a little piece of that graph there. But with those shapes in mind, let's go and complete our table so that we can graph this piecewise function. So starting with the first table, remember from the first video, if a number shows up in the inequality for your piece, you need to put it in the table. And yes, I know it says x is less than 2. 2 is not included in that piece. So all that means is that when I get this point, we plot it as an open point. But we still need 2 in the table so that we can have that open point there. I need more x values that are less than 2. I will also use 0 and I'll use negative 2. For these values, I'm just picking any values that are less than 2. I like to have at least 3 values in the table. I'm just using some more values that are smaller than 2. When we plug in 2, we get out 0. When we plug in 0, we get out 4, a positive 4. And that's coming, just to show you, that's coming from that, which is negative 2 squared, which is a positive 4. And when we plug in negative 2, negative 2 is going to give us a big number. We're going to have negative 2 minus 2 squared, which is negative 4 squared, which is 16. Now, it's going to be kind of difficult for me to get up to 16 on my graph. I could do it if I adjust my scale, but just to make things easier for us, I'm going to change this x value to negative 1. Remember, I said it doesn't matter where those values come from as long as they are less than 2. So now this is giving me negative 3 squared, which is a 9. And I can fit that on my graph easier. So that's just one thing to keep in mind when you're making tables. Try to choose values that aren't going to make your graph go off your paper or go off the scale that you have. Moving on to our next table. First things first, numbers show up in the inequality. 2 is the smallest number that shows up in the inequality. It needs to be first in the table. 7 is the largest number that shows up in the inequality. It needs to be last in the table. And I'll choose one other number in between. I'll just choose 5. Now, plugging into negative 3, there's no x value there in that function. There's nothing to plug into. No matter what x value you plug out, you just get negative 3. That's a constant function. Now, let's talk about what's happening on the endpoints of this graph. The 2 has an or equal to in that piece of the inequality. X is greater than or equal to 2. Because of the or equal to, this point 2 negative 3 is going to be closed. But the 7 does not have an or equal to. This inequality here for the 7, that just says x is strictly less than 7. 7 is not included. And so we're going to plot that as an open point. So now that we have our table set up, let's go in and graph. So the point 2, 0, I have an open point there. I'm looking at the first point on my purple table. I have the point 0, 4. It's right there. And I have the point negative 1, 9. This would be 6. That would be 8. That would be 9. Okay, there's the point negative 1, 9. Remember, the entire graph was a parabola that was shifted 2 units to the right. Entire graph looked like that. We're only seeing half of it. So I'm going to connect these points like that. So don't try to connect them to look like a line, because it's not a piece of a line. It's a piece of a parabola, so it should look curved. Let's go on and plot the points for our second piece. We have the point 2, negative 3. That is down here. We have the point 5, negative 3. I'm just going to move over some. And then we also have the point 7, negative 3. And the point 7, negative 3 is an open point. Okay? You don't have to worry about points that didn't come from the endpoints. Those will always be closed. And I'm going to connect those 3 points there. So now I have the graph of this piecewise function. Now that we have the graph done, let's take a look at the domain and the range. Starting with the domain, I'm going to make a number line, and I'm going to make sure that on my number line I'm hitting the numbers that show up in the restrictions. So I definitely want to make sure that I have 2 and 7 in my number line, because both of those show up on the restrictions. Let's start with the purple piece. The purple piece says x is less than or equal to 2. So 2 is not included in the purple piece, so I'll put an open circle on it and I'll shade over to the left, showing that x is less than or equal to 2. For the next piece, the green piece, it says x is between 2 and 7, but 2 is included because that inequality has the or equal to. So I'll put a closed circle on 2. That closes up that open circle. And 7 is not included. So I'll put an open circle on 7. And x can be anything between 2 and 7. Bigger than 2, but smaller than 7. So stop shading at 7. And now to get the domain, we're going to read the shading from left to right. Starting all the way off at the left, the shading starts at negative infinity. Continuing to move right. Don't stop when you get to 2. Because the closed circle on 2 closed it in and 2 is included. So keep going all the way until the shading stops at 7. But 7 is not included, and so it gets a parentheses. Infinities always get parentheses, and because that 7 had an open circle, it gets an infinity. We could also envision the domain graphically, and to do this, sometimes it's helpful to exaggerate your graph. So what I mean by that is, this graph here, it's going to continue to go up and slowly creep over to the right. So you can see this extended piece that I've put in here. It's not to the right, to the left. It's continuing to creep to the left. So if you were a little ant walking along the x-axis, as you look up and down, and you're walking on the x-axis because domain deals with x-axis. If you look up and down, starting from negative infinity, you would see the function when you looked up, because that purple piece continues to creep out to the left. And as you continue to move along the x-axis as a little ant looking up, you continue to see the function. When you get to 2 on the x-axis, right there where that open circle is, now you see the function if you look down, because it was open on the purple piece on 2. So you don't see the purple piece when you look up at 2, but you do see the green piece when you look down at 2, because that's a closed circle. And as you continue to move along the x-axis, you'll be seeing the green piece until you get to 7. Once you get past 7, if you look up and down, you will no longer see the function. So once you're past 7, you're out of the domain. Now that we have the domain down, and we've talked about how to find it from the graph, that was with the ant crawling around, and we also talked about how to find it from the inequalities. Now let's talk about the range. The range is not so clear to find from the inequalities. The range, it's best to have the graph when you're looking for the range. So again, starting at the bottom of the y-axis, because range deals with y values, you're a little ant moving up the y-axis, go from the bottom to the top. As you look right and left, you do not see the function, not until you get up to negative 3. Now when you're at negative 3 and you look right, you see that little piece of the function. So negative 3 is definitely in the range. But as soon as you get past negative 3, here's negative 3 right here. As soon as you get past negative 3, so once you're in this space here, when you look right and you look left, you will not see the function. not again until you get up to 0. So in other words, what I'm saying is that between -3 and 0, this region here on the y-axis, none of that is in the range. So -3 is a lone number in the range. So when I write that in the range, I'm just going to put -3 in curly brackets, signifying that it's by itself. And then I will union that with the next time I am in the range, which was when the ant was at 0. So now I'm going to start at 0, but there's an open circle right there. When you're at 0 and you look right, you see an open circle. So that 0 itself is not in the range. You can see something, but you're seeing an open circle. You're not included. But once you get past 0 and continue to move up the y-axis, you will see the function if you look to the right, or eventually if you look to the left. So all the way from 0 up to positive infinity, and infinities always get parentheses, are in the range. And again, that 0 got the parenthesis because of that open circle right there once you got to 0 on the y-axis. So that takes care of the domain and range of this piecewise function. The last thing we're going to talk about are the intercepts of this piecewise function. Let's just go look at the graph really quickly to see what we can expect. Looking at the graph, we can see that our graph does have a y-intercept. It's hitting the y-axis at that point right there. And it does not have an x-intercept. Do not look at that open point right there and say that that's an x-intercept. It is not, because it is open. So it is not an x-intercept. Let's go and find those algebraically. I'm going to start with the y-intercept because that's the easiest to find. You find the y-intercept of any function by setting x equal to 0. Plug in 0 for x. But when you're doing it with a piecewise function, at this point you have to figure out which piece of the function do I use if I want to plug in 0. Think back to the beginning when we did piecewise evaluation. These examples up here, when we had to choose which piece of the function we were going to use. Which piece of the function are we going to use if we're plugging in 0? 0 is less than 2, so I'm going to use the first piece. So I'm going to replace this x right here with 0. So I have 0 minus 2 squared, which is -2 squared, which is a positive 4. So this y-intercept of the graph is happening at the point 0, 4, which again, I'll point out, we knew that already from our table. We had plugged in 0 into that function. There's the y-intercept right there. I think I was covering it. The y-intercept right there of 0, 4. Now that we have the y-intercept, let's go on and find our x-intercept. You find the x-intercept by setting the function equal to 0. Our function has two pieces. We need to set both pieces equal to 0. I'm going to set the x minus 2 squared equal to 0. And don't write -3 equals 0. It does not equal 0. As a math teacher, that makes me cringe. -3 does not equal 0. You can just write that, and that shows that there's no way that that piece -3 could give you an x-intercept. Remember, if we just think about what -3 looks like on a graph, y is equal to -3. This horizontal gray line is never going to hit the x-axis. So we definitely don't get any x-intercepts from that second piece of the function. Let's go see what the first piece of the function could give us. I'm going to square root both sides of this equation to get rid of that squared. I should mention, when you square root both sides, you need to put the plus or minus. It does not matter for this example because we have 0 on the other side, and plus or minus 0 is still 0. But the square root cancels the square on the left and just leaves us with x minus 2, and then I'll add 2 to both sides of the equation to get that x is equal to 2. Now we cannot just automatically assume that that 2 is going to give us an x-intercept. We have to think about the conditions from that piece of the function. X less than 2. This x value of 2 does not satisfy that inequality. 2 is not smaller than 2. It's equal to 2. And so because that inequality fails, 2, 0 is not an x-intercept. So we have seen that both algebraically with what we just did here, and we also saw it graphically with that open circle at the point 2, 0. And that concludes finding the intercepts for this piecewise function. Hey everybody, I hope that video was helpful to you, especially if you've seen example 1. Hopefully now you're getting a better feel for piecewise functions. Please give this video a thumbs up, like it, comment any questions you may have, subscribe to my channel, and like Nancy Pie said, you don't have to like math, but you can like my video. Bye everybody, see you next time.